mass spectrometer, we identified two major isotopes for carbon. Carbon-12, meaning 12 total nucleons, protons and neutrons, and carbon-13, containing one more neutron than the carbon-12. So let's look a little bit more carefully as to what we're talking about here, and we'll define our terms a little bit. Remember, first of all, the nucleus has a volume much smaller than the total volume of the atom. And inside the nucleus is where we find the protons and the neutrons. The rest of the space occupied by the atom is just simply electrons. Okay? Now, the difference between carbon-12 and carbon-13, we said, was one neutron. Notice that the number of protons in carbon-12 and carbon-13 are exactly the same. And in fact, the number of protons defines those atoms as being carbon. So we oftentimes will describe that in this notation here. You'll notice the C for carbon. The 12 above is the mass number. That simply is telling you the total number of nucleons, total number of protons and neutrons. The lower number, if you see a lower number, sometimes this is not there, is the atomic number, and that tells you the number of protons. Well, notice that the atomic number for both carbon-12 and carbon-13 is 6. It's exactly the same. And again, what defines these two guys as carbon is that they have 6 protons. If we put in another proton, we get a different atomic number and therefore a different element. Okay? So in addition to carbon-12 and carbon-13, we also actually have another isotope that is not abundant enough in the Earth, on the Earth's surface, to be significant to us, but it is in fact important because it's a radioactive element. The nucleus is in fact not stable. We'll have lots more to say about that later, but you may have heard of radioactive dating or carbon dating, and that has to do with the decomposition of this nucleus. And so we'll talk more about that a little bit later. But right now, again, the point is, of all of these isotopes, they all have 6 protons, identifying them as carbon, and varying numbers of neutrons. Therefore, their mass number changes. When I say then carbon-14, again, I'm identifying it as carbon, 6 protons, 14 neutrons, 14 nucleons total, so therefore it must have 8 neutrons in this case. Mind bites.